Let's solve a linear system together. This linear system has two linear equations and two unknowns, 5x plus 2y equals 8, and 10x minus 5y equals 7. Now, you can do many algebraic maneuvers to solve this system for x and y. However, we're going to use something called Gauss's method. Now, Gauss's method has a restricted set of operations and a particular goal. The operations are we can multiply a row by a number, we can add one row to another row, and we can swap rows. Here, we're just going to use the first two. We're going to multiply this first one by -2. See, the goal is to get the leading term in each row so nothing's below it. So since 5x is the leading term in the first row, we need to get rid of the 10x, there'll be nothing below it. Since the second equation is the end, there's already nothing below the 5y. So when we get it in that form, we say it's an echelon form. So let's change this system so that we multiply the first row by -2. Now, we're not going to change the second one, but we'll copy the whole system over here to see the new system. So we'll have minus 10x minus 4y equals minus 16. We repeat the other one without change. Okay, so that completes the first operation. And now we're going to transform this using a second one of the row operations, which is to add the first row to the second row. And we're not going to change the first row, so we'll copy that. Without change. And then we'll write down here the sum of these two, the first one and the second one. Well, minus 10x and 10x, you add those together, you get 0, so we'll leave nothing there. Minus 4 plus minus 5 is minus 9y. And that's going to equal minus 16 plus 7, which is minus 9. Okay, now we have a linear system, which is an echelon form because nothing's below the leading term 10x in the first row, nothing's below the leading term in the second row. And then we're going to use a method called back substitution to solve this simplified or transformed linear system. So let's do that. Well, you can obviously see that by dividing out by minus 9 on both sides, we can find that y equals 1. This method is called back substitution because you start from the bottom and go back up to higher rows. Okay, then we substitute this into the second row, the first row that is, and get the second equation of the first equation of minus 10x minus 4 equals minus 16. We can since it only has one variable in it, we can solve it for x, and we find that minus 10x equals minus, adding 4 to both sides, minus 12, and so x equals 12/10, which equals 6/4, which equals 3/2. Now let's check and see. 2 times 6 is 12. That's not quite right. Okay, so we're going to have 6/5. And that is the answer. Okay, now, but how do you, I made a mistake here, right? An arithmetic mistake. And so how do we check? It's a good idea to check that we actually have the right solution. And so we need to do a check, which is to check that it's correct. Okay. And what we can do is we can say 5 times 6/5 plus 2 should equal 8. That's not a very good 5. Let's make that a little bit clearer. Okay. The 5 here and the 5 in the denominator here, which also isn't very well written. Okay. Cancel out, and 6 plus 2 is 8, so that's good. And the second row is 10 times 6/5. minus 5 times 1, which is 5, equals 7. Well, the 10 here and the 5 produce 2. 2 times 6 is 12. 12 minus 5 is 7, so the check works. Now, this isn't quite the end because we're looking for the solution set. So the solution set S equals the ordered pair x first, 6/5, and 1. So that's the answer, and this is an example of Gauss's method.